Shaki's email said just the title of my talk, which is JavaScript devs don't get lost, and I was having lunch with someone yesterday who was on the list and sadly is not here. And he said, whoa, you're talking and it sounds amazing, and is there going to be some kind of existential crisis about how you get lost in code or something? It's not. It's about that kind of getting lost. As Shaki said, now maps and driving around, and maybe not driving around in a kiddie car. Anyway, so as you probably know, a map is a thing that you use on the internet. And Google Maps is fairly famous. It was probably not the first, but the first big and popular way of embedding a map in your web page. And so that's like a lot of people I speak to are like, isn't that the answer? And that's like end of story. You just embed Google Maps. This is a picture, by the way, of some pretty cool artwork that a guy did in Google Maps style at the Google Maps office. And that's cool. This is one of Google's example use cases of Google Maps. That's the cycling trails around Stockholm. And like it's cool. It's a picture and it shows some cycle trails and stuff. But there's actually a lot of good reasons to not use Google Maps. Almost among them that what they call the Maps API is really, I don't know if I'm going to offend anyone if there's any Googles in the room, but the Maps API, I wouldn't call it a particularly rich API. It's a way to embed a map in a web page. You can do a basic thing like show me the cycling directions from here to here. It's not so fantastic for visualizing data. It's not so fantastic. We'll see later for projecting. For using different map projections, which we'll come to. It's not as sophisticated as the other kind of mapping GIS software that's out there. And so there's this interesting scenario. There's this interesting case, that GIS software is like this established thing, and there's all these crazy expensive things that you can buy from companies like Esri that cost a fortune and are horrendously terrible to use. That, for example, your local government will use if you want to submit, if you want to add a patio to your house and you have to submit a planning approval document. So someone will have to sit there and take your form and be like, all right, I'm going to look at the map of the local council now and see where that sits relative to the property line, blah, blah, blah. And that's been like an established field for 15, 20 years. But a lot of that software hasn't moved. And so what has happened in the last couple of years, and we'll see shortly, is that there's all this exciting new open source stuff, most of it on the internet, that is really cool and does the vast majority of what you'd ever want to do. But just at a basic level, just thinking back, what I just showed you with Google Maps was just a picture of Stockholm, basically. And if you just wanted to do that, you can actually, you can just draw a picture. You can just use Raphael or Snap or D3. Which is what we will do now as an illustration of kind of some of the things that you can do, I guess. So suppose today's little random code walking into the shell exercise is that we're going to draw a map picture-y thing of Sydney. And again, the old answer would be just embed Google Maps and then say map center equals somewhere in the middle of Sydney. But we're going to do a bit more than that. We're going to go to the Bureau of Statistics website, which is profoundly terrible, and if you ever have to go there, you'll probably want to tear out your eyes. We're going to download something from that horrendous URL up there. Whoops. And then we use a tool called Olga to Olga, which you'll see shortly. Basically, just the thing that they make, the thing the Bureau of Statistics make available is what's called a shapefile. That's actually a proprietary format by Esri, the company I mentioned before. Shapefiles are basically just a definition of polygons, shapes on a map. The shapefile is very common. It's pretty much every program in that world supports it. So these guys publish the shapes that they use for the census. So when you fill out your census form, a collector comes back, tags the number on it that says this form went to this house. And then they need a way of saying, well, this is the aggregation of forms that belong to this suburb, or this local government, or this postcode, or that kind of thing. So all of that information actually quite conveniently is available on their website. We're going to use, that Olga to Olga tool, which is part of an open source library again called GDAL. It's probably 5 years old, 6 years old, and does things like convert between every map format into every other map format. And there's a format called GeoJSON, which we're going to see. In fact, I can show you now. It looks like this. It's verbose, but kind of works. It's just a JavaScript object or a JSON object with an array of features, and each feature has geometry, which is like points on a map, basically. And like I was saying, it's a bunch of shapes, and then they have names and things like that. That bit of code up there at the top, for anyone not familiar with d3.js, d3.json just says send an AJAX request to load this JavaScript file, and then do stuff. So we're going to do stuff. We're going to draw the suburb boundaries that we've just loaded. We're going to create an SVG element, and then I'll skip over that bit in the middle, and then we're going to load our GeoJSON file and do this line here, svg.append. Is just, if you're not familiar with SV scalable vector graphics, the kind of basic unit. There's a few basic units you can slap on a circle or a rectangle, but for a complicated shape, you define a path, which is just a polygon with various points. And we're going to do that with the map features that we've loaded. And it looks like this, which is, kind of looks vaguely sort of like Sydney, not really. There's obviously no features within the giant black morass, but we'll come to that. Coming back to this, the line at the bottom there, d3.geo.path.projection, is the kind of the magic which I am going to hand wave about and then not say anything else about. It basically converts the shapes that are defined in the GeoJSON file into points for the SVG document that you're seeing on the page there. I will not go into further detail. Anyway, it's a black blob, right? So maybe we want some more details. For example, as I was just saying to you, the Bureau of Statistics has published this shapefile as a way of cataloging census records, which means that it's got all of the little suburb boundaries, and it's got all of the little sort of subunits. So what we'll do is we'll draw those as instead of drawing the big block. So we do this, which I don't know how familiar everyone is with D3. Skipping over the complexities of the sort of the theory of how the logic of how D3 is done. We're just saying, create this SVG element, select the path elements, and then we're going to replace them. So if there aren't any there already, it doesn't matter. We're going to use the map features data that as I mentioned, just came from that GeoJSON file, and then we're going to enter the features, which was that array that we saw. Whoops, back here, this array. We're going to enter that array, and just for each shape, for each element in the array, we're going to create a path, and we're going to call it suburb. So this looks like this, which doesn't really show up so clearly on the projector. But if you look really closely, there are very small dotted lines. Anyway, the point of that is that these are all a bunch of individual SVG elements for each suburb. And the great thing about SVG is that it only requires some CSS to style it. So I set a kind of palish blue, not quite the sea color, and then we've given a red border to each of the suburbs. And now it's kind of starting to look more like a sensible map. It's like it's got all the boundaries. You could imagine taking this, for instance, and then having some statistic that's represents each suburb, something like population density or the average income or how awesome the suburb is, and color coding it. So that's we'll stop the foray into D3 here, and then I'll come back to it shortly. But that's kind of that's how you would draw a picture in D3, basically. Similar to, like I was saying, if you're just using Google Maps for a picture, you can do this with publicly available data. Anyway, maybe you're looking at this and saying, this is really boring. I want a map that I can drag around and zoom and have my cat crawl over. And you would be right. That is, like, depending on what you're trying to do, that's pretty cool. So, perhaps more interestingly, there's a bunch of really cool open source tools that allow you to do this. The older one is called OpenLayers. OpenLayers has been around for a good couple of years now, and it's cool, but also kind of I guess a bit older. It supports everything under the kitchen sink. The thing about OpenLayers is that it's great. You just have to kind of bend over backwards and then stand on one foot and hop sideways while waving your arms and wearing your lucky socks to make it do exactly what you want. To give you an example of using OpenLayers, this is something that is a bit stretched. But this is something that some friends of mine did at a hack day called GovHack earlier last year now. That won a prize. It's obviously a picture of Antarctica, but it's a mashup of data from the Australian Antarctic Division, Bureau, whatever they're called, of all the different human research stations in Antarctica and of planes flying across Antarctica, and there's a point somewhere that's like seals and penguins swimming around that have been geotagged by someone's research, which, that's a pretty cool map. The cool thing about this, though, is that it's Antarctica. And I mentioned very briefly in passing before about map projections. The thing about one of the problems with Google Maps is that it has a fixed projection. It's what's called a spherical Mercator projection. The Mercator projection is really common. It's very likely that every map you've seen for like 90% of your life is Mercator projection. But if you look at Antarctica, it's kind of ballooned out of all ridiculousness. That is not what Antarctica actually looks like, as you've probably guessed. So my friends used open layers and used not a custom projection, but I forget which projection they used, but they used some off-the-shelf library code that plugged into open layers, plugged some other things in to draw a nice map of Antarctica. They sourced some ice photography from somewhere else as well to overlay that on top. Anyway, just as an illustration of what you can do with open layers. I don't know if there's any West Wing fans in the audience, but there's a side diversion on this note of projections. There's an episode in the West Wing that talks about Big Block of Cheese Day, and then these guys come up and they present about how normal Mercator projection maps suck, and so they should use the Peters projection, which is in that little picture there. And CJ, the redhead one's response is, no, I'm not confused, I'm just wondering where France really is. The Peters projection, by the way, is one of the other, probably the second or third most common map projection out there. Anyway, that's enough rambling about open layers. Open layers is cool, especially for using alternative projections, but it's not, in my opinion, it's not the awesomest of options for putting a map in a web page. In my opinion, Leaflet is cool, and the most awesome option. It's not very old. It's like 18 months old, maybe 2 years, which means everything's been written with modern techniques. It's HTML5 and CSS3 buzzword compliant, but more importantly, it works on mobile. It takes advantage of more recent language features like even just simple stuff like being able to for each an array. This is an example of a leaflet map. You can't see the controls. Oh well. This is just from China, from Mapbox, which we'll come back to. Leaflet's strength is that when you create a leaflet map, what it actually does is it creates a bunch of layers. That's the official term. Like Photoshop layers, there's what's called a tile layer, which is the base of your map. That's the picture that you see here of the names in Chinese. Obviously, I did not write those. And then there are other layers stacked on top, and you can add plugins, or you can add your own code that adds additional layers. The Google Maps API does the same thing, and OpenLayers actually does the same thing. That's kind of in the name. But Leaflet's strength is that it actually makes it a lot easier. It's kind of the central design of Leaflet is around the layers, so it's a lot easier to work with layers in Leaflet than it is with, for instance, the Google Maps JavaScript. That bottom layer of the tile, the picture of the map, can come from. It's very easy in Leaflet to replace the tile layer or use different places. You can use the Google Maps. You can use tiles from Google Maps if you want to, or you can use tiles from these guys, Mapbox or CloudMade, which generate. They are tile servers. They generate tiles from data that's in OpenStreetMap. There's half a dozen others half a dozen other people that provide tile service too. There's a company called Stamen Design in the States that are moderately famous for their watercolor tiles that you might have seen scattered around the internet. And it's also not too hard to, well, that's a lie. It's moderately hard to roll your own tile server, take a dump of OpenStreetMap and then generate your own tiles. Anyway, the tiles are tiles. They're just lots and lots of absolutely positioned images. The idea is that you start with your map contains any number of layers. There's a base layer which is just a bunch of images, and then you can add additional layers on top of that if you want to add visualization, or if you want to add notes or annotations or anything like that. On this note, Leaflet is actually, there's some examples on the Leaflet website of using it as something that's not a map. So things like documents or historic books that have been scanned at really high resolution, and then viewing the images of the book as kind of cut up, lots of little cut up tiles. The other strength of Leaflet is that it's a popular open source project. It has a strong plugin community, and hopefully this will work. And I can show you some things like this. This is a plugin called Leaflet Market Clustering. It does a few things like this, where it shows you the regions for which it's clustered little points. Again, Google Maps API does this too, but not with as much cute animation, or with as much customizability. Another example is this plugin called Leaflet.draw, which lets you draw lines and polygons and things and circles and stick points on the map, and it's not that exciting, but it's a way to add a layer, add stuff onto that layer, and annotate the map. A slightly cooler demo, but this is called Osm Building. Sorry, some of the people in the OpenStreetMap project have clearly that this is Central Berlin. There's a little towery thing there, and that's actually rendered in 3D. That's doing some kind of subtle perspective shifting there. Again, on top of, you can kind of see underneath there's a base map that's coming from Mapbox. Those are the tiles, and then there's another layer on top of that that's WebGL. That's the shape of the buildings. Whoops. So you might have seen this comic from Doghouse Diaries. The best maps, in my opinion, are not actually the basic maps, or indeed maps of the picture of the building or anything. In my opinion, the best maps are visualizations that say things like Australia leads the world in deadly animals. It's what my American friends keep asking me about. So let me spend the remainder of my talk in the time that I have rambling about visualizations to you, and we're going to come back to D3JS in a second. I'm going to show you an example that another friend of mine put together, working for a company called Kinetic, that's an outsourcing firm, tracking phones, which is kind of not low tech, not that exciting, but one of his responsibilities is looking after the call center for these guys. And they were he was looking through the logs of every call they received in a year, something like that, and basically plotting the origin of the call, and then drawing a Bezier curve down to the call center, which is obviously down there in Perth. It's amusing because he's actually a Microsoft C# kind of he's most experienced with Microsoft Stack and the C#. And he found this article in the MSDN magazine that was talking about Bing maps, and talking about drawing Bezier curves in there. I'll skip through it, but there's a bit of code down here somewhere that's for how that basically goes into quite a bit of detail about drawing a Bezier curve on a map and how it depends on what projection you're using, and Bing uses a slightly different projection to other mapping services and stuff like that. But again, talking about the flexibility of Leaflet and the fact that it's very easy to plug in and to draw additional stuff on layers, he took that code and then used it to basically just draw these red Bezier lines that show the calls coming from various different locations, and then a crap ton of calls coming from, there's an office up there somewhere in Osborne Park or something. Anyway, the second example that I wanted to show you and ramble in a little bit more detail about is a little bit closer to home. Let's talk about SydJS. That is, if you recognize the lovely announcement email that Sharky sent out about a week ago that I mentioned earlier. Those of you who are new to SydJS won't know that we used to be Atlassian, used to be across town on Sussex Street by Darling Harbour, in another beautiful heritage building. And then about a year ago, Atlassian moved, and then the meetup moved with them. So it occurred to me, there's all these. We had a ton of talks, obviously. Pretty much each month, Sharky sends out an email that's the titles of some of the descriptions, of the talks. So I took that data. I took the words. I took the titles of the talks and the people giving them from when we used to be at the old Atlassian building on Sussex Street. And then I took a collection of the emails that I could find in my email. Hopefully I haven't deleted any of the talk titles from this location. Right up to Tom's talk today on Cognizance that hasn't happened yet. I'm excited to see what that's going to be about. So all I've done here is just obviously taken the words, done a very basic and very stupid manual filter of splitting them on spaces and then making them separate, each word as a separate array element. There's actually correct ways of doing this, but I'll come back to that. I threw it into this tool, which is a word cloud. You've probably seen these. They're horrendous, and many people are ideologically opposed to them. Because as a visualization, it's actually a pretty bad visualization. It doesn't tell you particularly interesting things about your data. But it's also fun. If this is going to load, no. Let's try again. Maybe. Oh, fail. Oh well. It's a pretty way of taking a ton of words and then giving you something pretty from the words. Obviously, it's some words are bigger, and also the colors vary as well in response to how frequently the word is mentioned, or there are more sophisticated versions of this where they try to cluster the words or do smarter things with them and then highlight them based on that. Again, it's not the best way to visualize this kind of data, but it looks pretty. And then I thought, well, so if I make a word cloud, then wouldn't it be cute to put that on a map, given that we have two different locations? So let me walk you through the code that I wrote to do that. On that note of me manually splitting up the words, there are actually correct techniques. This is actually my day job. There are correct techniques for data mining of the large text sets. I didn't use any of them because I was feeling lazy. So I wrote this. It's not very smart. Don't look at it. It burns my eyes. What I'm doing here is taking the words out of the emails, splitting the text into words, into array elements for each word, looking through a not very smart list of some stop words because they're pretty common, and then just counting how frequently the words occur, and also counting what is the most frequent occurrence. Again, there are tools. There's NLP processing toolkits. There are things like Word2Vec that would be the correct way to do this if I was actually serious. But whatever. Taking that slightly worked up set of words, I then wrote my own version of the thing that won't load. Yeah. Wrote my own version. That's an open source thing that's built on top of D3.js. But it's a plugin to D3. D3 and D3's plugin architecture is a bit of a black art, so I won't go into much detail there about how it works. But basically, it's that same step at the beginning where we're creating an SVG element, and then we add text elements to it, obviously because it's text. By this line again, that I mentioned before, you attach the data to a particular bit of SVG, you enter the data, which is the count of the words, and then for each word, you create a text element and have this magical function here that, or a previous magical function that sets the size and then sets that is set on the element as the rendered size. And we're using the typeface impact because, it's an ugly word cloud, so we might as well be ugly and go back to 1994. This last step, the last thing that I mentioned, on this page is this line at the bottom, the Svg Translate, that says that once you put in a text element, obviously by default a text element just looks like a bit of text on a web page. It's flat left to right, and whatever color you set. So we're going to rotate it by a certain amount to make it go sideways, and we're also going to translate it, which means move it to different positions. There's some more code that does the calculations that I was hand-waving before. That's d3.layout.cloud is the reference to the actual plugin itself. You define the target size of the whole cloud, and then you do some stuff about you do some stuff to define the functions by which you calculate the rotations and the font size and stuff like that. I'll skip over this code because it's a little bit weird, a little bit crazy. Fairly well optimized actually though. There's weird things like this that I had to look up. Tilde in JavaScript is a binary not, and so double tilde is actually just doing a binary not of the number and then binary notting it again and then ending up with an integer. So it's basically just a stupid hacked up way to do math.law, but anyway. That gives us the word cloud that looks something like this. but it's still kind of boring because it's still just like words on my page of my kind of yellowish background, and that's not very exciting. So let's create a map. This is what the basic code for getting started with Leaflet looks like. You just define an element that's going to be your map. You load the JavaScript. You also have to load a CSS file. You say new l.map, and you set its center. This center is somewhere just over there, probably on King Street. And you define, as I was saying before, you can use different tile layers with Leaflet. So we're going to define a tile layer. This is the URL format of tiles from CloudMade, who I mentioned very briefly before. CloudMade at one point was sponsoring Leaflet development, and then the guy left CloudMade and now works for Mapbox. The map looks like this. You know, cool, but not that cool. It's kind of what I was batting out before as being just a picture of stuff, which it is. So then we're going to get Leaflet's overlay pane, which is a layer that it creates for you by default. Kind of meant for you to add stuff into if you don't need to add anything enormously complicated that's like panning and zooming and moving all over the place. We're going to add an SVG element to it, which is that line at the bottom there. This is from heavily adapted from a tutorial that Mike Bostock published. Mike Bostock is the D3 guy who's like one-man coding machine. And then we're going to render the clouds that we just saw. We're going to render them into that SVG element rather than just randomly on the page. I skipped over that pretty quickly, but we didn't apply that translate, that SVG translate that I mentioned before, isn't applied here because the map it's a leaflet map. It's interactive. It can be panned and zoomed. So we have to do something to deal with that. Leaflet publishes a series of events. There's one called moveEnd, which is fired when the user stops moving. So when the user is dragged around and then stops the dragging or has finished zooming. So we're going to respond to that with a little function that I wrote, or somewhat wrote, called reset_svg. It's not the best bit of code in the world, but whatever. It calculates rather clunkily the distance that you've panned and the scale by which you've zoomed in or out. And then really all it does is it resizes the SVG image in response to that. So if you zoom out 2 times, then it makes the SVG image 2 times bigger or smaller in correspondence with that. So there's also a bit of glue code, which I'll skip over because I'm probably running over time, but it runs that code once to begin with and then generates stores the original values for the width and height. And then, hopefully this will work, we get something that looks like this. So, thank you. So obviously there were more talks at Sussex Street than there have been over here. But based on this, I conclude that people here have been talking more about introductions to, that's a bit dark grey there, but BlackBerry has been a popular topic here, and making stuff for you has been a popular thing here. Whereas over at Sussex Street, JavaScript for you is the thing. What was that? Anyway, so the bit of code that I showed you before is responding to the zoom elements. We can zoom out on it, we can zoom in and say, oh, that word says rant, or whatever. Anyway, moving along. That's pretty much my talk. I'm just going to spend a little bit of time at the end rambling about the future and lolcuts. There's a lot of cool stuff coming in the Leaflet world, or the mapping world, the online mapping world, I think, in the not too distant future. One thing that I'm excited about is this stuff. There are companies called Skybox and Planet Labs and a handful of others that are launching things like that. That's called a CubeSat. It's about this big, and it's a satellite. It's like a full-blown open source hardware satellite that costs, like, it weighs about 1.5 kilograms, so it costs in the order of like $100,000 to launch rather than $100 million to launch. Which means that it's a lot easier to launch a bunch of these and then take photos of the Earth so that you can get them, so that then there's more competition for access to that, to the tile layer, to the images that you want to put on your map. This is an example that Skybox published just a few weeks ago from Perth. This is the casino in Perth. It's fairly high resolution. It doesn't come out so well on the projector. It's fairly high resolution. There's a company that's kind of half-based in Sydney called Nearmap that specialized in publishing very high-resolution aerial images across the company, but especially across the country, but especially for mining companies and agricultural companies and governments. This is like most of the quality of Nearmap, at a fraction of the price. Skybox are taking advantage of free launch slots to charge not hundreds of thousands of dollars for their images. So it's pretty cool that there's a bunch of, you could envisage their satellites taking more than just straight photographs, but doing other kinds of analysis of the world for, again, relatively cheaply. Another cool thing is that I'll very briefly talk about is that maps are entering the third dimension. So coming back to Google Maps and the fact that the API is not as good as Leaflet, there's actually still lots of cool stuff. This is the preview version of Google Maps, which most of you have probably seen. This is the same location in Perth. There's the casino. This is slightly older because this building has not been demolished yet, but what I wanted to point out is that they do image processing on, I'm pretty sure, Street View data, and also do laser altimetry to do things like this. This bridge and these trees and all of the buildings, and there's a power pole being rendered in 3D. So this hasn't been done by a person. This has been, this is big data aggregation, collecting 3D imagery for vast swathes of the world. At the moment, this 3D is only available in Perth, I believe, because there were service providers, the mining companies, already flying their planes around. But it's rapidly being rolled out. It's rolled out in San Francisco. It's just the other day they were tweeting about if you see a low-flying plane in Canberra, it's just us. Don't worry. So Canberra's coming soon, and obviously they're going to expand as much as possible to other locations. Anyway, on that note, I think I will wrap up. But thank you. And questions, please.
That's what I was going to say. Questions, please. No questions. We all exactly understand how to employ all the mapping technology we need. Or we don't need maps. You know where you're going. Even better.
Question from the front.
I just want to say it's an awesome talk, but also just wondering about how in the first, I think, few slides, how did you manage to convert the government data into like SVG?
Oh, sure. So I probably skipped over that with too much speed, but the government data is published in a proprietary format called Esri shapefiles. That's already got everything you need. It's already got the bounds and the shapes. And really the magic happens in this line here. This tool, Ogre2Ogre, is a component of the GDAL library, that's open source geographic data abstraction layer, I think. And that can convert, what it does is basically converts from pretty much any mapping format into any other mapping format. So in this case, we've generated JSON from that, and then we've used D3 D3 already knows how to interpret pretty much every JSON file in the universe, so we generate SVG from that, if that answers the question, hopefully. Other questions?
One more question? One more question, there we go.
So it sounds like you're obviously very knowledgeable in the topic. Can you tell me a little bit about like what you do day to day in your 9 to 5 for this stuff? Like what kind of projects have you been working on? Like how would you use this in a practical sense outside of what you've been talking about?
I'm not sure if you guys heard the question. The question is how would you use this in a practical sense? Let me show you if the internet works. This is not very exciting. It's also very beta, but it's not very exciting. And it's not a paid job. It's a favor for a friend. But anyway, my friend sells houses. I don't know, real estate doesn't really excite me. But anyway, this is, with a bit of help from me, we're building a website about calculating how much finance you can spend on your house and how much of a house you can own. And obviously also a key question with houses is where can you build a house? So this is a leaflet map using, I don't think the icon's going to show it, but using the Mapbox tiles. Showing GeoJSON overlays. So I've used, as I mentioned, Leaflet is all about layers. I've used one of the built-in Leaflet layers, which is specifically there for adding stuff from a GeoJSON file. We generate on the server. We generate a GeoJSON file for the different suburbs that are available and the prices of them. And so you can do things like click on a particular bit of land and see what land is available there. That's probably a better example. And so, if you want to spend $152,000, then you could live in this far-off middle of nowhere suburb. Hopefully that answers the question.
Okay, great. Thanks very much.
Can we all thank Varun, please?